Hi, I'm George, welcome to GMakes, and this is how to make a procedural pixel transition in Blender. Check it out. So here I am in a brand new scene in Blender, and I'm going to start off by deleting our default cube and our light. I'm going to keep the camera just because I'll need it later. I'm going to reset its position and location and move it up just a little bit because I'm just going to want it shooting down like that. And yeah, so the basic premise of this is we are going to start with a plane, and we are going to use geometry nodes. But first things first, I want to set up my plane. So I do want this 16:9 aspect ratio for this transition. So you can check what you're in. The standard is 16:9 is the default setting. If you're doing 4K or something, you can multiply this, make this bigger. But I'm good with this. I also do want a fair bit of geometry and scale. Just for this, you don't necessarily need to, but I'm going to scale this up by 5. And also that's why my camera, I pull it up. As you can see now, my camera is much too small. So I'm also going to set my camera to view, and I'm just going to scroll out until I get nothing too exact, but just there. And these edges don't have to be perfect, because when we do a geometry node, as you'll see, it will expand a little bit around the border. But you can do it to your liking. I'm just gonna go right there. Perfect. You can see, if you want to do something more specific, you can use the tool or items or the view settings up here. But anyway, that's where I'm at. And because you could also scale this to be 16:9, this rectangle, but because I want to keep my little pixels that you'll see, I want them to be squares and not rectangles. I'm going to start with a square. I'm going to head into edit mode. I'm going to right click to subdivide and choose something that 10 is the max it will allow you to slide to. So if you want big pixels, you could do something around there. I'm going to do something moderately large, not as small as maybe it was in my intro, but you can maybe 20. It's still not quite perfectly lined up, so maybe 25. We'll see, we're getting there. So I think I'm liking 25. I guess not perfectly in the corners or anything. Doesn't necessarily need to be. It's just a transition. I like the size of the square and everything, so I'm just going to start with that. I'm going to then click out or hit enter, and I'm going to go back into my object mode. The last thing I can do actually while I'm still in this window is you can delete those extra, because you won't be needing them. So I'm going to select them, and I'm going to delete those vertices. Delete a little too much there. So, because I want those last ones. And you can always come back and clean up, because I might not, you'll see with geometry nodes, I might have enough area to actually cover the edge without needing this top row. But I'll fix that once I see how this looks with geometry nodes. So I'm going to open up a new window down here. I'm going to keep my timeline for now. And we're going to go into the geometry node editor. And here we are. We're going to make sure our plane is selected, and we're going to hit new. And now we got a new geometry node set up down here. Lovely. So the reason why we subdivided this mesh is because we want all of those points, because we're going to do my favorite thing, which is instance on points right here. So we don't need to distribute points in a random or Poisson distribution because we already have a whole bunch of points on this mesh, all the vertices of this mesh, the way we subdivided it. But we do need something to instance. I'm just going to go with a grid because it's low geometry, and you could do squares or rectangles or cubes or something like that, but why? And you can mess with this, of course. You can choose a different object. And you can see that's much too big. Instead of messing with my grid dimensions, I'm just going to mess with the scale over here, and I'm going to change it so it's just one node. I don't have to mess with all 3 of these. So I'm just going to use a value, and I'm going to click up. Even that 0.1 is maybe too big. So I'm just going to do the exact science of just typing in numbers until I hone it in. What I want is I don't want any gaps in this, but I also don't really want them to overlap. They overlap a little bit, that's okay. But the ideal is that they're perfectly synced. So that was too big, so I just need 0.075. Still not 0.7. Let's try 8. And that looks like it's just too big. So like I said, in exact science, we're going to go with 0.077 right there. that might be still a little too small if these gaps are persisting. So if it's too obvious, then I know I can just go back up to 0.78. But I'm happy with that right now. If I go back to my camera view, and you can see if I turn off this modifier now, I don't really need that top row because it was already covering it with my squares, my instances. So I'm going to delete those vertices and get back out into object mode, and there we go. Perfect. So there we go. That's the premise. That's all we've set up. That's all we really need to start is we have our squares, our little grids, instanced on our mesh, on our grid. But now we're going to make this actual transition. And this is a little bit mathy node setup, but nothing too terrible. We're going to start with a capture attribute node right here. We're going to put that right in, and we're going to grab the attribute we're going to capture is going to be the position. And this is the position of, we're going to set this, we can keep this as points and float. So this will capture the position of all of the vertices, all the little points. So every time, right now it's the center of all these squares. And then it's going to output as a floating point value. So it's going to output as a single decimal number. It's not going to output the X, Y, and Z. If it was, you can choose to do that, which will be covered in part 2 to do some cool things. But we're going to start out with just the float value. And so now we're going to go ahead and do our first little mathy. So we're going to insert your good old math node right there, and not right there, but we're going to put this above here, and we're going to take this attribute, and we're going to plug that into the top. And then we're going to take our value and plug that into rotation, because the whole idea of this, and you can even see, if we go back up, you can see it's taking each point and it's giving us the rotation. So from this bottom corner up to here. And that's pretty darn cool. And of course, this is using add, so it keeps adding as it goes. But we're going to do something a little more interesting, and we're going to use a greater than. So you can see it's already kind of giving us what we want. So if we mess with this threshold number, you see it turns, and that's the animation in a nutshell, right there. But you can see these aren't being hidden. Like if we go back and we click out of here, you can see the back face of them. So one way to get rid of that is in here, in your kind of viewer settings, you can turn on backface culling. And so now these still aren't quite the back face, but you can see over here where we start to see they start to flip more over. They start to disappear. And we'll also be able to do that with our textures. If we stay in Eevee as a render engine, we're able to do that with the textures as well. So that's very useful. But how do we fix this? Well, the answer is more math, which is always fun. So I'm just going to duplicate this math node. We're going to put it right in there. And then we're going to multiply. We're going to change it to multiply. And you see what that's already done. It's already fixed a lot of stuff right there. And now we're getting into how this actually works. So basically what's happening is this greater than value, which you can also change it to any of these other comparison to really get this kind of transition. This greater than value is taking this output value, which again is a floating point number of any of the vertex positions. So all of these little dots that are now the origin of each one of these squares. It's taking that and it's comparing it to whatever this threshold value is. And if this top value is greater than this bottom value, it is then multiplying, it's then taking it and giving it an output of 1. If this value, this bottom value, is instead greater than this top value, it's giving an output of 0, because then that's greater than is not true. So that's all fun and games, but what does it mean? Well, it means that if you take that and then you put it into rotation, that's your rotation. So your rotation is then either 1 or 0. And we're going to do a fun thing with annotations right now, because this is a little mathy and it helps to maybe keep some things in mind. So if we go over here and I make a new annotation for you, blah, 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 there we go. So this is what's driving it, all right? And if the top value, like I said, is greater than the threshold, then it equals 1, because it's true. Greater than is true then. If the value is less than the threshold, we get an output of 0. And then that output is going into rotation, to the rotation right here. But the real question is, what does that do? What does that mean, the 1? Well, it's not 1 degree, as you can kind of tell up here. What it really is it is 1 radian, or 0 radians. And a radian is equivalent to roughly 57.3 degrees. So either we're getting an output of 57.3 degrees, or we're getting an output of 0 degrees. What we want, we like that 0 degrees. So that is when this threshold gets us here. That is when this threshold is bigger than the value, we're getting 0. So all the rotation is being zeroed out. And we want that for the starting value as well, except we don't want 0 because we don't want the front face where there's going to be a material. We want the back face where there's going to be nothing. So what do? Well, this is the most mathy this is really going to get right now. So what we do is, first of all, you can see up here that this, first I'm going to quickly hide that annotation for you. So we can see that this is also rotating on the X, Y, and Z axis. And first thing, we only want to deal with one axis. You can, at a minimum, we don't want to be dealing with the Z axis because we don't want this kind of rotation. So we're also going to do a combine X, Y, Z and put that in and only want the X output. You can also do another one of these multiplies and do the Y output, but it doesn't really change anything. And so to kind of also further demonstrate my point that I was saying with the radians, that our output is 1 radian, which is 57.3 degrees. And a radian is the radius with pi. You don't need to know that. Go to 8th grade math or Google it, or I don't know. I didn't do math in college, but here I am doing math on Blender. But here we go. So we have that rotation. And then if I get rid of the rotation, and right now, of course, this is all set to 0, which is our ideal ending position. But if I take that X and I just do 57.3 degrees, I think this might flip it. So it might be negative for the one I have right now. But yeah, you're going to see negative 57.3. Actually, the reason why that was negative, we're going to go back to my normal 57, is I'm going to multiply this by, we're going to just even turn off this multiply because we don't need it right now. But if we go here and we plug this into rotation, nothing changes because it is output of 1 radian. Like I said, it is an output of 1 radian, which equals 57.3 degrees. So there we go. And so then that's why we have this multiply node, which if we take it, and the way to solve this issue is if we take this multiply node, all right, if we take this multiply, and we need to multiply this value right here, 57.3, we need to multiply that value by some number, by n, to equal 180 degrees, because we want this back face. Of course, we want this. This is 0, and this is 180. We want it completely turned around. So what is n? Well, n is pretty self-explanatory. Without going too much into it, n equals pi. But that's, of course, pi radians, which is equivalent to 180 degrees. And why does that work? Because what we're doing is if pi radians equals 180 degrees, then we're just multiplying the output of this greater than, which again is 1 radian. So it's 1 radian times pi radians, which equals, of course, everyone's favorite, pi radians, which is equal to 180 degrees. That's math for y'all, folks. Again, it's nothing. It's a little bit, I guess, trigonometry is what that is. You don't need to understand that. So maybe I put a time code in here to skip all the math. Maybe I didn't. You just click through it. But either way, this gives us an output of 1 or 0. And then to make this 1 be what we want, we got to multiply this by pi. So that's what we're going to do. That's what we're going to do, folks. So to clear all that math, yucky math, get that out of the way, we're going to take this. So we have our output right here, and it's plugged into our rotation. We have it separated, or combined, really. So we're just, again, this is one value. We're not having 3 separate x, y, and z. But we're plugging this single value into our x coordinate and outputting only our x rotation. So nothing else is moving. And then we just type in here, we go 3.142, and look at that. It flips over. And again, we're not going to see this if I click out of it because up here in our settings, we have backface culling. If I turn that off, you can see them again. And then if I go on my camera and I select my plane, there they are. But if I go and I mess with this threshold value, we're going to get that nice animation. And that's the gist of it. So now we're going to animate this just so we can see it a little bit better. I'm just going to go 10 frames in the future. I'm also going to go to my render settings. I want to make sure you don't really need to change the FPS because I'm going to export this, or I like exporting these transitions as a PNG sequence or an EXR. You can, any image sequence that has transparency, just because then I'm not stuck to one frame rate if I want to use this for different footage. But you can also export it just right ahead as an any kind of video file. So with transparency as well, so probably an RGB, or not an RGB, but probably a QuickTime animation file or something like that that has the RGBA or RGB plus alpha. But either way, I'm going to go to there. I'm going to find by clicking through where this point is. It's right there. I'm going to hit I to add a keyframe on my threshold value. And then now this will be exactly 1. So I know I have 0.06, negative 0.06 as my when all these back faces, because if we turn around, everything's just flipped over. And so I'm going to go instead, and I'm going to go, we'll go to 80, and we'll make my N 90. And so now I'm going to go and just type 0.6, and you'll see they're all flipped over. I'm going to hit I again, and there, we're back. And so now if we play this, we're going to get a nice little animation where it follows through and goes there. All right, so the next and last step for this tutorial, part 1. Again, part 2 will mess around with some more of these math nodes and some more things you can do. Like if you want to put an image on this, I'll go over how to do that things. So if you actually want to use this to make like an intro on like a wall or something, and you don't want to do any post compositing, that's going to be covered in part 2. Part 1 right now, to finish this off, we're just going to go ahead and make this usable as a transition. So to do that, first things first is we're going to get a set material node, put that right there, but we don't have any material. Oh no. I'm going to choose the default material because I'm just going to edit that. I don't need to make a new one. I'm just going to pull this over and switch to our shader editor. And now I'm going to select our material, which right now is just a white material, base principled BDSF. But we're going to use an emission material. Again, we're sticking in Eevee, which is also really nice for rendering. So we're going to use an emission material just so that we don't have to light our world. If we go to the world viewpoint, the whatever viewport shading, you can see I don't have an HDR, any lighting. I deleted the light, but yet I still have color unless I do here and then it's dark. So we're going to use an emission shader. Also, one thing we're going to make sure to do, since we don't have any lighting and we also want this to be transparent, is in the render settings, we're going to go to film and we're going to click transparent. You see the world should go from the gray color to being having no color in the background. And this, if you forget to do this step, it will just mean you're going to have to render again or be like, why isn't my footage transparent? So just make sure to hit this film. Of course, if you want a different background color, you could also change the world color, but I want it to be transparent. So I could leave it as a white color like this, but just to make it kind of classic and easier on myself, I'm going to switch to green. So now if we play this back, you can see nothing is happening. And why is nothing happening? Well, it's because our material, our viewport has backface culling, so the back faces are transparent. Again, if we go here, you can see it's working. But our viewpoint, but our color, our material, our shader does not. Again, why we're in Eevee is so that we can go to the settings. If we go to the material that's on here and we hit backface culling. That's all we need to do. Look, it already fixed itself, and there we go, it's playing. And you could do motion blur. You don't really need it because nothing's really moving. It's pretty much just flipping a switch from on to off. So you're not really going to gain anything by motion blur. So might as well save yourself the little bit of render time. And that's the animation. And the reason why I did green here is not really because I'm going to green screen it out because it's already transparent. But whatever solid color you use, I just did green because it looks kind of nice, or like it's very classic, like a chroma key. But you could do really like any color. You could do a blue. You could do something. You just need something solid and very contrasty, because the way to use this transition is to go into a program like After Effects or another editing software, and then you can use a track matte. So basically saying I want to use this footage right here, none of the transparent stuff, this footage as a matte for my footage. So anything that's behind this will be visible. Now you could also, if you want to use cubes or something, you could make the back face a different color, like a green, and then just chroma key that out, or make that an image again. If you want to make an image and use it, that's going to be in part 2 of this tutorial, so stick around for that when that comes out and go ahead and watch it. But that's this tutorial, so that is going to be it. Hopefully that wasn't too confusing. Hopefully you understood it. Hopefully you have some ideas on how to make cool transitions like this. Again, it's fully procedural at this point. It isn't until a little bit later when we start adding images and stuff that it starts to become less procedural. But like I said, you can change anything. If you want to mess with your scale down here for whatever reason, you can. If you want to, let's say I want to make this, for whatever reason, I want to make this a circle, a sphere. So let's get an icosphere in here. And now this icosphere is what I'm using. And it's still going to work. It's not going to have a back face per se, but you can see around these edges. And if I go here, you can see it is moving. So if you just want to rotate that icosphere along the x-axis, you can do that. But like I said, fully procedural. Yeah, and that is how to make a cool and pretty simple, pretty straightforward pixel kind of loading animation. Or overtaking animation, whatever you want to call it, in Blender. So again, I hope you enjoyed it. I've been George. Hope you learned something. Hope you stick around for part 2 when that comes out, so we get a little more advanced with this. Hope the math wasn't too confusing. You don't need to know the math, so hopefully you might have also just skipped over the math, because it's not necessary. Just know that we use a greater than, we multiply by pi, we combine it just to get the x value, and then we output. And then bada bing, bada boom, you get a cool animation. So that's it. That's the tutorial. Hope you enjoyed it. Subscribe for more of these. And again, when part 2 comes out, maybe want to be subscribed so you don't miss that. And I'll catch you next time. Take care.